Hello everybody and welcome to another YouTube video. So in today's video, I'm going to be covering while loops. Now while loops are a more general type of loop in C++ and just any programming language in general. Anything you can do with a for loop, you can actually replicate with a while loop, but a while loop is more powerful, it can do other things as well. So with that said, let me talk to you about while loops in this video. So before we dive in, I'm just going to quickly mention why I haven't covered something called for each loops. If you don't know what a for each loop is, don't worry about it. It's just something that allows you to iterate by item in an array or some data structure that's iterable. Again, don't worry about that if you don't know what that means. The reason I haven't covered that yet is because it uses some more advanced syntax and symbols that we haven't yet seen. And so in the interest of not confusing anyone and actually being able to explain the syntax fully, I'm going to show that in some later videos. Anyways, in this video, we're talking about while loops. So let's compare a while loop to a for loop, and let's do a quick kind of refresher on for loops. So I'm going to type out a for loop here. I'm going to say while int I is equal to 0, I is less than 10, and then I plus plus, and then I'm going to see out, and we'll just see out I, and then end L. All right, so this is a basic for loop. We're going to print the numbers from 0 to 9. We're not going to do 10 because its I is less than 10. And well, that is a for loop. We defined our iterator variable. We defined our condition. This loop runs while this condition is true. And then we do something to the variable at the end of the loop. So a while loop is actually very similar to a for loop, except we're not constrained to the fact of having to use some iterator variable. So here we have to define some variable, right? And this variable is what tells us how many times we're looping. And if you remember back to the previous video, I said you would use a for loop when you know how many times you want to loop. So that's great, but here we have to know how many times we want to loop. Like we have to loop 10 times, 20 times, 30 times, some number of times we have to define that. And even if we're looping through an array, we're looping through the number of elements in the array, right? Or some variation of that. So now we talk about a while loop. Now a while loop is the exact same as this, except we don't have this iterator variable that we need to define. So what you say when you define a while loop is while, you do your open and closing parentheses, and then you have your curly braces like this. And while this condition is true, whatever's inside of these parentheses right here, this loop is going to run. So a little bit different than the for loop, and then in that you don't have to define these two things right here, but you do need some condition. Now this condition can literally be whatever you want. Like in this case, I'm using true. That means I'm going to have an infinite loop here because this while loop will just continually run forever. This condition true is always going to be true. But if I were to put, say, false here, then, well, this is going to never run, right? Because this condition is false and it's never going to change to true. So the idea behind this while loop is that we don't need to use a condition that depends on some iterator variable. We can use some condition that kind of says we don't know how many times we're going to be running. Now, to give you an idea of what I mean by that, when you would use a while loop, a really classic example is when you're asking user for valid input. So you want the user to type a number. Maybe you want them to type either the number 1 or the number 2. Those are the only two valid options for whatever program you're writing. Well, you want them to type in the number 1 or 2. Like they have to type in that number for your program to continue. So you're going to keep asking them to type in the number 1 or 2 until eventually they type it in. You don't know how many times they're going to give you invalid input. You don't know how many times they're not going to give you any input at all. So you're going to use a while loop because, well, you don't know when that condition they typed 1 or 2 is going to be true. So I'll show you what I mean, but I want to show you how we can simulate a for loop with a while loop. Because again, anything you can do with a for loop, you can do with a while loop. So let me define some iterator. I'm going to say int I, and then here, let's make this equal to 0. And then as the condition, I'm going to say I is less than 10. And then I'm going to say I plus plus. And before I do the plus plus, I'm just going to see out this exact same thing. So let me just run this code here. When I do this, you're going to see that what we get is 0 to 9. And then we get 0 to 9. So the exact same thing happened from both of these statements right here. This while loop does the exact same thing that this for loop does. Now, hopefully you can see why I maybe preferred to use the for loop This is just a bit of a cleaner syntax. You don't have to write as many lines of code, all of the stuff related to your iterator variables in one line. This is kind of the preferred style. You should really never write a while loop that's exactly like this. It would make much more sense to write a for loop, but the idea behind a while loop is it's much more general, whereas the for loop is kind of a specific type of loop and just makes things a little bit cleaner when you need this type of functionality. So now let's erase this for loop, and let me show you a real practical use of a while loop. So we want to get some valid input from the user. So we're going to ask the user to type in some number. We're going to store whatever number they type in, and then we're going to check if that number is equal to whatever options we have. So in this case, let's say 1 or 2. So let's do this. I'm going to clear out this while loop, and I'm just going to set the condition for my while loop to be equal to true to start. I'm going to make a variable here. I'm going to say int input. We'll just leave it undefined for right now. And then I'm going to ask the user to type something in. So I'm going to say cout. I'm going to say type the number 1 or 2 colon. Okay. Then I'm going to say cin, and I'm going to cin to the variable input. So what I'm going to do now is I want to check if this input is equal to 1 or 2. If it's equal to 1 or 2, I can stop my loop because they've typed in valid input. If it's not equal to 1 or 2, then we need to keep looping, keep asking them to type in something valid. Now for this example here, I'm going to kind of ignore the fact that the user could type in a string or something that's not a number. We're just not going to deal with handling that right now. We're going to assume they give us some number, and we're just going to check if that number is equal to 1 or 2. So I'm going to say while, and in this case, the input is not equal to 1, and the input is not equal to 2. So what we're pretty much saying here is while the input is not equal to 1 and not equal to 2, keep looping. So if at any point in time they type in 1 or they type in 2, then we're going to stop. And just to show you a little trick here, if you want to see what needs to be true for the loop to stop, so like the opposite of this, like you want to know the condition that has to be true for the loop to stop running, then what you can do is apply a not to this condition. So if I copy all of this and I put this down here and apply a not to it, then what this gives me, if I have the not, is I take the not, apply it to the left, apply it to the right, and then swap the logical operator. So that's going to give me input is equal to 1, or input is equal to 2. So this means if the input's equal to 1 or the input's equal to 2, this while loop stops. And that's because when you apply the not to this condition, well, that's what it tells you, right? Because if this is not true, then that means the loop stops running. So if this is true, this condition right here, the loop will stop running. So hopefully that makes it clear, but just a little trick in case you have difficulty reading some of these conditions. But anyways, that's what it means. Now, as I said here, when we start out input, it doesn't really have a value. So we actually don't know what the value of input will be. So just to kind of safeguard us a little bit, I'm going to set input equal to -1 to start, and we're just going to keep asking the user to type something in. So this is not necessarily the best practice to do this, but for the purpose of this example, I'm just going to do it this way. Anyways, let me go to my terminal now. The reason I have to go to my terminal and I can't run this in Sublime Text is because Sublime Text is not capable of actually capturing user input, at least in C++. It will kind of work, but then it will break halfway through. Anyways, I have to go here and do it. So I'm going to compile my program. I'm going to say tutorial 11, and then ask me to type the number 1 or 2. So if I type 3, ask me to type another one, type 4, ask me to keep typing, I type 1, boom, we're done. Run this again, I type 2, we're done. Run this again, I type a number, another number, type 2, we're done. So you can see in every single one of these programs, I typed a different number of numbers, right? Like the loop ran a different number of times. And that is where a while loop is helpful, because we don't know at the beginning of the program how many times I'm going to make a mistake or not give something valid. And so that's why we use a while loop. So hopefully that kind of clears it up. But now I'm going to show you another way that we can end a while loop or a for loop. So the next two things I'm going to show you here are called the break and continue keyword. Very important. I probably should have shown them in the previous video, and they apply to both a while loop and a for loop. So I'm going to change this now to be while true. And I'm going to show you how even though we have a true here, we can actually end this while loop from inside of it. This is kind of just a different pattern or paradigm of doing things. Sometimes there's like reasons why you would want to do this. So it is very important that you understand the break and continue keyword. Anyways, let me show it to you. So I want to end this while loop. Now there's this keyword, it's called break. You can see how it's highlighting kind of here in red. Whenever your program hits a break keyword, it's going to break out of the closest loop that it's inside of. What I mean by this is that when you see break, it's going to look kind of outside of the break keyword and find whatever loop it's inside of. The closest loop it finds, because you can nest loops inside of each other, it's going to break, and by break, just immediately end. So anything after the break keyword, say I see out like hi, will not run, because immediately when you hit this keyword, as soon as the program sees this, boom, loop is done. Anything after is not going to continue running. Even if you're in a for loop, the entire for loop is finished running. Doesn't matter what the I variable was at. That is what the break keyword does. So to use the break keyword, well, I only want to break when something happens, right? When a condition is true. So I'm going to say if now, and we're going to change this. We're going to say if input is equal to 1, or input is equal to 2, then break. So now notice how this condition here is different than the condition I put up here. It's the negation of it, right? Now, if I apply a not to this, that's going to give me the while loop condition I should have. So here we're typing in the condition that needs to occur for us to end the loop, not the condition that needs to occur for us to continue running the loop. So in a lot of cases, it's much simpler to write this condition, the one that just uses the or, doesn't have the and the not equal to, than it is to write the other version, right? So that is sometimes why I use a break keyword to simplify the expression or simplify the condition that you're using to kind of control the flow of the while loop. Hopefully that makes sense, but that's one of the reasons why you'd use a break keyword, because oftentimes it's easier just to break out when something happens than it is to write all of the things that need to be true to continue running the loop. Anyways, let's just see if this works. So let's go here, let's run this, or compile, and then run. I'm gonna type a number, 4, 3, 2, boom, we're done. Type a number, 1, we're done. So it is working. Again, does the exact same thing as the previous loop. Instead, now we are using break. So that's how the break keyword works. Now you can use multiple instances of the break keyword, right? Maybe I have another condition. If the input is equal to 4, then maybe I want to see out cool, and then I want to break. That's totally fine. Now I have 2 break conditions. So if either of these things are true, I want to break. And really, we can change this to an else if, right? And the reason we could change that to an else if is because if this is true, well, we're just going to break. So we can change it to an else if. Now, it doesn't matter if it's an if or if it's an else if, but we could change it, just showing you that there. So let's run this. Let's go tutorial 11. Let's type a number, 5. Let's type 4. It says cool, and we end. So there you go. This indeed works. So that's the break keyword. And just like you can use this in a for loop, you can use this, or sorry, just like you can use this in a while loop, you can use this in a for loop. So we will continue in 1 second, but I need to quickly thank the sponsor of this video and this series, which is Algo Expert. Algo Expert is the best platform to use to prepare for your software engineering coding interviews. They have over 140 coding interview questions, and more are constantly being added to the platform. Check out Algo Expert from the link in the description and use the code TechWithTim for a discount on the platform. So let me delete all of this. Let me quickly show it to you in a for loop. So I say int I equals 0, I less than 5, I plus plus. I'll say if, and let's just go I equals 2, then cout done, and then break, and we will just cout I and L. Okay. So let's just run this for loop, and I'll just show you that this works. I can run this in Sublime Text. So notice that we break as soon as we get to 2. The reason we broke at 2 is because, well, this condition was true. We saw the break keyword, and we ended. Now, it's important to note that, again, you're breaking out of the most recent loop. So if I wrap a while loop, so I say, like, while true, and then I wrap the for loop inside of this while loop, totally valid to do this, by the way. You can put a for loop in a while loop. There's nothing wrong with that. If I do this now, when I hit this break keyword, I'm just breaking out of this for loop. And so what will continue to happen here is I will keep printing 0, 1, 2, 0, 1, 2, 0, 1, 2, because this for loop will keep running because we're in an infinite while loop. And then what's going to happen is, well, it's going to run until it gets to 2. It's going to break at 2 and then continue running again, continue running again. So let's make this non-infinite loop. Let's say int j equals 0. Oops, I keep typing 9. We'll say while j is less than 3. And then at the bottom of the loop, we'll say j++. And there we go. So now let's run this and let's see what our output actually is. So let me just move this up. Let's run. We get 0, 1, 2, done. 0, 1, 2, done, 0, 1, 2, right? And there you go, because we're printing done whenever we break this loop, and well, this for loop runs 3 times. So hopefully that's kind of clear, but that's how the break keyword works. Now we can talk about the continue keyword. So the continue keyword is kind of a way of continuing looping, but skipping the rest of the stuff for the current iteration. So I'm going to clear this kind of wrapped stuff because it's a little bit hard to read. I'm going to make another for loop. So we're going to say for int I equals 0. We'll say I is less than 10, and we'll say I plus plus. Now for this, right, I want to say skip every even number or every odd number, or maybe when it's a certain number, I want to do something. When it's another number, I don't want to do something. Maybe for the number like 8 and 9, I don't want to print it out, but all of the other numbers, I want to print it out. Now, you could try to change this kind of iterator to do that for you, but I'm going to show you how the continue keyword works regardless, because there's a lot of use cases where you do want to use it. So what I'm going to do now is I'm going to say if, and here I'll say if I is equal to 9 or I is equal to 7, then continue. Now, whenever you see the continue keyword, what this will do is immediately bring you to the next iteration of the loop. So as soon as you see this, the loop doesn't necessarily end, but it just goes to the next step. So if we're at 9, or sorry, let's 7's a better example. If we're at 7, we're just immediately going to go to iteration 8 and start the for loop from the very beginning. That means anything underneath here, so say C outing I, is not going to happen. So if this condition is true and we continue, we don't print out the number. So let me show you what I mean. Let's run this here. You're going to get 0, 1, 2, 3, 4, 5. And notice we skip 7 and we skip 9. That is because we have the continue. So as soon as you hit the continue, you skip anything afterwards. Hopefully that's clear, but very useful, because a lot of times when you're looping, you want to check some type of condition or do something. But if that is true, maybe there's a bunch of operations you can skip. And so rather than say wrapping the opposite condition, which I'm going to show you in 1 second, you can use this continue keyword. So if you didn't have this continue keyword and you wanted to do what I just showed you, you would have to do this in kind of a very backwards way. You'd have to say if I equals 9 or I equals 7, then you could like do nothing inside of here. And then you could write an else statement here. And then in the else, you could print this out. So only if I is not equal to 9 or not equal to 7 are you doing this, right? That would work. But that just doesn't really make much sense. So what a lot of people would do is they would say, okay, well, instead of doing that, I'm going to remove this continue, because imagine we don't have this continue keyword. I'm going to put this inside of here. I'm going to change this now to say if I is not equal to 9 and I is not equal to 7, right? So now what you're saying is, okay, only if I is not equal to 9 or not equal to 7 am I doing this. But again, this is kind of like a backwards way of doing this, because really you should do it in the opposite order. You should have your condition be simpler. So you say if I is equal to 9 or I is equal to 7, we're just going to continue the loop, as opposed to here where you're checking every single time if I is equal to 9 or I is equal to 7, and only if it's not equal to those two values are you printing these out. So you can make an argument for why one or the other is better. Let's just run this and make sure it does indeed work. But continue is very useful, and you'll see why it becomes useful, because now if I wanted to do like a ton of different things, right? Say I wanted to do this, like I wanted to print this out a bunch of times. Now, again, we would just use a loop to do this, but imagine we had like, 200 lines of code or something inside of this for loop. I don't really want to have all of these lines of code indented. As soon as I add layers of indentation, my code just becomes a little bit more difficult to read. It's not kind of clean and nice. And so all of the stuff that I want to happen, I'm putting inside of this if statement, when really it would be better if I could flip this around. So I could put all of my code not indented, although I am going to have to unindent this. So if I can move it all unindented, and then I can change this here. So the only thing that's indented is that continue, right? That's just like a little bit cleaner and a better style when it comes to coding. Now I'm getting a bit ahead of myself here, because we don't really care about industry standards and that kind of stuff when we're learning a programming language, but just something to keep in mind when this continue word will actually be useful, because a lot of people I think see these types of syntax or words and are like, well, why are you showing this to me? I'm like never going to use that. Okay, so sorry for the abrupt cut here, but now I want to talk to you about something called the do while loop. Now, the do while loop allows you to make sure that whatever's in your while loop runs at least one time. To show you why this is useful, let's consider the following example. Let's say I have some variable. I'm going to say int x is equal to 10. Okay, so int x is equal to 10. And then what I want to do is I'm going to say while x is less than 10, I want the user to type in a number. So the idea behind my program here is I'm going to ask the user to add some numbers to x. And while the value of x is less than what it started at, so it's less than 10, I want them to keep adding numbers. Essentially, I want them to make x greater than 10, right? However, greater than or equal to 10. So they need to type in anything that's 0 or above. However, if I run this while loop right now, like let's put something inside of here, this isn't going to run. The reason it won't run is because, well, 10 is not less than 10. And so the initial condition is false, which means I'm never going to enter this while loop. Anyways, let's just say int add like that. And then we can say cout. We'll say type a number and then to add to x colon. Okay. And then we'll say cin and we will cin to add. And then we will say x plus equals add. And then we will just cout x is colon x and then end L. Okay, so I know I went kind of fast there, but the idea is we're asking the user to type a number. They type in a number, we store it in add. We then add whatever number they typed into x. We print out what x is. If x is less than 10, we continue running. So we want this to run at least one time, because what might happen, right, is if the user types in like -1, then that means that we're going to keep running this while loop. So after the initial entry, they may be in this while loop many times, but they need to enter the while loop. So to do that, we need to make sure we can enter inside of here. Because if I run this, go to my terminal and G++, and then run tutorial 11, nothing happens. One way that we can make this run is we could just copy all of this code, right? So we could copy all of this. We could put this here. And then let me just erase the initialization of add just because I can't reinitialize a variable once I've initialized it. And now this will actually run. What I've done is I've taken all the code, copied outside of here. So this will happen one time. We'll then check if x is less than 10. And if it is, we'll continue repeating these steps right here. So let's try this. Let's compile. Let's run. It says type a number. Let's type like -2. And then it's going to keep asking us to type numbers. So if I type 4, boom, we're done. However, this is not very good. This is not good practice. I don't want to copy all of this code. And what if the code inside of here was, again, like 10,000 lines or something? I'm exaggerating, but what if it was very large? I don't want to copy all of it beforehand. So this is where the do while loop comes in. So keep in mind, this is what we had to do previously. Now, if we use the do while loop, what we can do is ensure that our loop will run at least one time. So I'm going to copy all of this. I'm going to put it inside of the do. So let's indent all of this. And then I'm going to put my condition. I'm going to say while x is less than 10. So this code right here is equivalent to all of this minus the int x equals 10 that we wrote above. And what this does is says, all right, we're going to do this. No matter what, we do this at least one time. Then after we do this, we check if we should do it again. While this thing is true, do all of the stuff inside of here, but it ensures that we do it at least once. And intuitively, it kind of reads that way, right? Because we do it, then we check, then we do it, then we check. Whereas up here, we're checking, then we're doing, we're checking, then we're doing. So it's kind of in that opposite order, which allows us to have this happen immediately at least one time. So let's erase all of this, and let's now see if this works. So let's go to our terminal, let's compile, and what is the problem? Oh, I need a semicolon. Sorry, just add a semicolon to the end of the while there. Let's compile. Let's run, and now it asks us to type a number. So if I type number like -6, it's going to say x is 4, -2, x is 2, that's 6, and then 11, and we stop running. So that is the do while loop. Really straightforward. You just put the do, whatever you want to happen, and then you add the condition afterwards after the while statement. So with that said, I think I'm going to end the video here. I hope you guys found this helpful. If you did, make sure to leave a like, subscribe, and I will see you in another YouTube video.